So now in this tutorial, we will discuss about the coordinate geometry for class 10th, right? So in class 9th, you already learnt about the basic concept of coordinate geometry, how to locate the point, how to represent the point on the coordinate axis, what are the coordinate axes, right? So let's see. First we have to discuss about the coordinate axis. Now, vertical straight line is called the y-axis and the horizontal line is called the x-axis, right? Now, so OX is the positive x-axis, OX dash is the negative x-axis, OY is the positive axis and OY dash is the negative y-axis, right? And the x-axis is called abscissa and y-axis is called ordinate and y-axis is called ordinate. Every point should be abscissa, comma, ordinate. Means first you have to write the x coordinate and then y coordinate, right? First x coordinate, then y coordinate with comma, right? So in the first quadrant, every point should be positive, positive. Means x-axis is positive as well as y-axis is also positive, right? In the second quadrant, why it is second quadrant? Always starting with the OX axis in anti-clockwise direction. Always start with OX axis in anti-clockwise direction. So up to 90 degree, this is first quadrant. 90 to 180 degree, this will be the second quadrant. 180 to 270 degree, this will be the third quadrant. And 270 to 360, this will be the fourth quadrant. So always we can consider the angle in positive direction. And you know, positive direction is called the anti-clockwise direction, right? So this is first quadrant, this is called the second quadrant, this is called the third quadrant, and this is called the fourth quadrant, right? So every point in the second quadrant is represented as negative, positive. Means x-axis negative and y-axis positive, right? Every point in the third quadrant will be negative, negative. Negative, negative means x-axis is negative and y-axis is also negative, right? Every point in the fourth quadrant as positive, negative means x-axis positive and y-axis negative, right? So these are the four coordinates: first quadrant, second quadrant, third quadrant and fourth quadrant, right? So you can represent a point on the coordinate axis by this way. Now if we have some zeros in the point, like if we have x coordinate is non-zero and y coordinate 0, so this will be the point lie on an x-axis. If we have plus a comma 0, this point must lie on the x-axis positive side. If we have minus a 0, must lie in the negative side, where a is any real number, any positive real number, right? In the y-axis, x coordinate must be 0, so we can represent this point as 0 comma b. So if we have abscissa 0 and ordinate non-zero, that point must lie on the y-axis. If we have ordinate 0 and abscissa non-zero, this point must lie on the x-axis. So these are the representation of the point which already learnt in the class 9. Now our first topic in class 10, which is distance formula. First topic is distance formula. So let's see what is distance formula and how can it be derived, right? Distance formula, let's see. Distance formula means we have to find the distance between any 2 points on the coordinate axis. With the help of this formula, we can find the distance between any 2 points on the coordinate axis, right? For example, let's derive this formula first, then we can apply this. First we have to make a coordinate axis xy. This is the coordinate axis xy, and let's consider any 2 points on the first quadrant. Generally, to derive a formula, we need to consider the point as positive to derive a formula. But A and B can be any point on the coordinate axis. It may be in third quadrant, it may be in fourth or second quadrant as well, right? Now, let's consider the coordinate of this point A as x1, y1 and the coordinate of point B as x2, y2, right? Consider the coordinate of point A at x1, y1 and coordinate of point B at x2, y2, right? Now, we have to find the distance between these 2 points. So, first of all, we need to discuss what to mean by x1, which length is called x1, which length is called y1, which length is called x2, which length is called y2. Let's see. If we draw a perpendicular from point A, let's see, if we draw a perpendicular from point A and name this as AP and draw another perpendicular from point B named as BQ, we can say this length OP is called x1, because if you have some point, for example 2, 3, if we have this point 2, 3, so this length will be 2 and this length will be 3. The length along x-axis is called abscissa and the length along y-axis is called ordinate, right? So we can say this length OP as x1, this length OP as x1, right, along x-axis, and the coordinate of this point is x2. So we can say the length along x-axis is called x2. So this length we can say x2, right? So we can say OP is x1 and OQ is x2. Now what do we mean by y1, y2? We can say this length AP is called y1 and this length BQ is called y2. We can say this length as y2 and this length we can say y1, right? So here we can say OP is equal to x1, OQ is equal to x2, AP we can say y1. Why? Because y coordinate is y1 and the y coordinate of point B is y2. That's why the length along y-axis is called BQ, which is equal to y2, right? So these are the lengths of x1, x2, y1 and y2, right? We have to find the length AB. To find AB, we need to draw one more perpendicular from point A to the line BQ. So we can write this perpendicular as AR is perpendicular to BQ. So we drawn some perpendiculars here. We drawn OP perpendicular to OX, we drawn BQ is perpendicular to OX, and we drawn a perpendicular AR to the line BQ. Why we drawn this perpendicular AR is perpendicular to BQ? Yes, to make this triangle as a right angle triangle, and this is the hypotenuse of this right angle triangle. Why? Because we know the length along x-axis and we know the every length along the y-axis. So now we know the value of AR and we know the value of BR in terms of x and y. So we can find the value of AB because this is the hypotenuse of this triangle, right angle triangle. Yes, let's see how can we derive this formula. So in right angle triangle ABR, we can say by Pythagoras theorem AB square is equal to AR square and plus BR square. So we can say AB square is equal to, what do you mean by AR? So the length AR is nothing but the length PQ, and which will be equal to OQ minus OP. So length of PQ can be written as x2 minus x1, which is called OQ minus OP. So this is equal to this length AR. So AR will be again x2 minus x1. So we can write it as x2 minus x1 whole square plus, what do you mean by BR? You can say this length is y2 and this length is y1. This is equal to this length. So y2 minus y1, which is equal to BR. So we can say this length is as y2 minus y1. So we can put as BR, y2 minus y1 whole square. Now therefore, finally AB can be written as square root of x2 minus x1 whole square plus, we can say y2 minus y1 whole square. This is the length of AB. So now AB is called square root of x2 minus x1 whole square and plus y2 minus y1 whole square. This is the length of AB and this is called the distance formula. Now we need to subtract the x coordinate and we need to subtract the y coordinate with the y coordinate. For example, if we have to find the distance between any 2 points, let's see if we have to find the distance between, the question is find the distance between the points A 3, 4 and B 1, minus 2. Let's see how to find the distance between these 2 points 3, 4 and 1, minus 2. A and P are any 2 points in the coordinate plane. So we can say this point at 3, 4 and this point we can say 1, minus 2. So we can consider the first point as x1, y1 and the second point as x2, y2, right? We can consider the first point as x1, y1 and we can consider the second point as x2, y2. So the first point as x1, y1, we can say 3 as x1, 4 as y1, 1 as x2, minus 2 as y2, right? So therefore, AB is equal to square root of x2 minus x1 whole square. We can apply this formula which we derived, y2 minus y1 whole square. So we can substitute this value, x2 minus x1 will get 1 minus 3 whole square and plus y2 minus y1 we can say minus 2 minus 4 whole square. It will be equal to square root of, 1 minus 3 minus 2 and minus 2 square will be 4 plus minus 2 minus 4 will be minus 6 and minus 6 square we can say 36. It will be square root of 40. Right? Square root of 40. We can simplify this. It will be square root of 4 multiplied 10. We can write 2 root 10 units. This is the distance between these 2 points. By this way we can find the distance between any 2 points, right? So now these points is not the numerical value only. It may be some algebraic expressions, it may be some trigonometric equation, it may be some numerical value as well, right? We can find the distance between A sin theta, B cos theta to A cos theta, B sin theta. It may be some numerical value, it may be in trigonometric, it may be in algebraic expression. For example, let's see one example with algebraic expression. Distance formula, we have some very important application of this formula, like if we have to find the distance between any 2 points P and Q and the coordinates are given in algebraic terms like A, comma A plus B, and the second we can say A minus B, comma B. Yeah, these are 2 points in algebraic term. This is not the numerical value. So we can apply the same formula. We can find the distance as square root of x2 minus x1 whole square plus y2 minus y1 whole square. You can also write it as x1 minus x2 whole square, because you know x1 minus x2 whole square is same as the x2 minus x1 whole square. Plus 2 square is same as the minus 2 square. That's why we can also take this as x1 minus x2 whole square. This we can take y1 minus y2 whole square. Right? So what are the value of x1, x2 here? So this is called x1, y1, these are called x2, y2. So we can say x1 as a, y1 as a plus b, x2 as a minus b, and y2 as b. Right? So we can apply the formula, we can substitute the value here, x2 as a minus b, and x1 as minus a whole square, plus y2 minus y1. We can say b minus a minus b whole square. So it will be equal to square root of, you can cancel a with a, minus b square will be b square, and plus you can cancel b with b, minus a square will be a square. So this will be equal to square root of a square plus b square unit. This is the length. The length must be in terms of a and b, because the question in terms of a and b. So the application of this distance formula is very important to proving the triangle is an equilateral triangle, the triangle is an isosceles triangle, a right angle triangle. If four vertices are given, we can say that quadrilateral form may be square, may be rectangle, parallelogram, rhombus. You must know the property of these triangles and quadrilateral. You can prove these things, right? So these are very important in distance formula. For example, if four vertices of a triangle are given, prove this four vertical will form the rectangle. So you need to prove the length of opposite sides are equal, and length of another opposite sides are equal, and length of diagonals are also same. If opposite sides are equal and diagonals are same, it will be the rectangle. If opposite sides are equal and diagonals are unequal, it will be the parallelogram. If all the four sides equal and diagonals are equal, it will be square. If all the four sides are equal and diagonals are unequal, it will be the rhombus. So if four vertices are given, we can prove this. In the case of triangle, if three vertices are given, we can prove these three vertices will form an equilateral triangle, an isosceles triangle, and a right angle triangle, or a scalene triangle. If three vertices are given, for example, three vertices like this is given, point A and B and C. If the points are given as 1, 2, 2 minus 1 and 3, 1. We can find the distance of AB, we can find the distance of BC, we can find the distance of AC. If all the three sides are equal, we can say this will be the equilateral triangle. If any two lengths are equal, we can say this is isosceles triangle, and if all the three sides are unequal, this will be the scalene triangle. If all the three sides are unequal and the square of the largest side is equal to the sum of square of other two sides, it will be the right angle triangle, right? So these are very important application of distance formula. In coordinate geometry, we will discuss about the section formula in the next class, right? Section formula and area of triangle, this will be the next part of this chapter. Now, you can solve the question related to distance formula, and if you have any doubt, you can ask me on my number, and you can WhatsApp me on email ID, and you can mail on email ID. So this is my contact number 96509 12288, and email ID is vishu@equalsign.in. You can note down this one. We'll discuss the section formula in the next tutorial. Thank you.